In this tutorial, we are going to create a login for our Dinogrow game in Flutter. Our goal is to help you create your own mobile game on any EVM-compatible network and also on Solana through a series of tutorials that tackle every part of the development process. We will be using Quicknode services. Quicknode is a leading blockchain development platform that offers fast and reliable nodes, APIs, IPFs, service, and much more. They are also the sponsors of this video. Let's open Visual Studio Code and run Flutter, create Dinogrow, and move to the Dinogrow folder. Create a .env file in the root, and create these three variables. We need to go to quicknode.com and create endpoints for Polygon Mumbai, Binance Testnet, and Solana DevNet, and place them in each variable accordingly. Now let's create an assets folder. Here we'll place logo images for our game and the networks we'll be using. Make the pubspec.yaml file look like this, with all the necessary libraries and the imports of the assets folder and .env files. Now create a pages folder with all these Dart files where we'll be writing our code. In the login.dart file, import these libraries. Now create a stateful widget. Login state. Create all these variables we are going to use. This function, checked for saved login, will read the storage and look for mnemonic and password. We'll call it in the init state. If no credentials found, it'll go to the setup route. Create a scaffold with a column like so. Its elements are the logo of our game, login text, a form widget with a column. Inside this column, a text form field to handle the password input. It verifies the submitted password and stored passwords are the same. If they are, it navigates to the select chain route. If not, it displays invalid password. Next is a login button with a function on submit. This function triggers the form validator. The last element is a button to use a different account. This triggers a function on different account press to confirm action and navigate to the setup route. In the setup account.dart file, import these libraries and create this setup screen stateless widget with a scaffold titled Setup Account with a column in the body. It will consist of one button to navigate to input praise to recover an account, and another to navigate to generate phrase route to create a new account. In the generate account file, import these libraries. Create this generate account screen stateful widget and create this variables. We'll create a function generate mnemonic where we'll generate a seed phrase using the beep39 library. This function will call it in the init state. Create a scaffold called seed phrase with a column. The first element will displace the seed generated. The second is an icon to copy the seed phrase to the clipboard. The third element is a checkbox that changes the copied variable and displays the text, I have stored the seed phrase. The last element is a button to either navigate back if the checkbox above is unchecked or to store the seed phrase in the device and navigate to the password setup route if it is. In the recover account file, import these libraries. Create a input phrase screen stateful widget. Create these variables. Create a scaffold with a column in its body. The scaffold will have a floating action button to navigate to the root. The first element is a title. Then, this form, where we use a grid view to generate 12 text form fields to receive each word of the seed phrase from the user. Then, if the validation of the form fails, we display this text on screen. The last element is a button to submit the form. It triggers a function onSubmit that will use the BIP39 library to validate the seed phrase. If it is a correct seed phrase, it will save it in the device's storage and will navigate to the password setup route. If validation fails, it enables a flag to display the validation fail text in the setup password file. Import these libraries. Create a setup password screen stateful widget. Create these variables. Create a scaffold with a setup password title and a column wrapped in a form, as shown on screen. First element is a text form field to enter the password. Second element is another text form field to confirm password. Last element is the button to submit the information. In the submit function, we trigger the validators to confirm passwords match. If they do, the password is written to the device's storage, and we navigate to the login page in the root. In the select chain file, import these libraries, create a select chain stateless widget, create this storage variable, create a scaffold titled select chain. The scaffold will have a floating action button to navigate back to the login, and in its body, it will have a column wrapped in a single child scroll view and a center widget. First element will be a circle avatar showing the Polygon text and logo. It is wrapped in a gesture detector, so if the user taps here, it'll trigger a right chain and navigate function with the context and the word Polygon as a parameter. This function will create soon. Second element is another circle avatar, showing the Binance Smart Chain logo and text, with the corresponding parameters for the right chain and navigate function. And the last element will be to display the Solana logo and text with the corresponding function call. The right chain and navigate function writes the name of the selected chain to the device's storage and navigates to the home root. In the homepage file, import these libraries. Create a stateful widget my homepage. Create all these variables. We call this function readChain in the init state. This async function will load the Quicknode RPC for the selected chain in the previous screen. To do this, it loads the .env file like so, reads the content assigned to the key chain in storage, and will also read the mnemonic from the device's storage. We update the chain variable in this set state. Now, depending on which chain is selected, we are going to read from the .env file the appropriate Quicknode RPC, like you see on screen, and we'll update the image to the corresponding logo. And for the EVM, compatible blockchains will call this balance EVM function to illustrate the process of connecting to the blockchain to retrieve the balance of our account. For Solana, we'll call a different function named balance Solana. The balance EVM function receives the RPC for the selected chain and the seed phrase. It will find the account address by passing the seed phrase to this mnemonic to seed hex function of the BIP30 library, and then obtaining the private key with this parameter, using the method fromHex of the eth_private key class in the Web3 Dart library. We only need the public key in the parameter address for now. To create an ETH client, we first create an HTTP client, and then construct a Web3 client class with the RPC and the HTTP client. We will store this as ETH8 client. We can now get the account balance using the getBalance method available for our ETH client, passing the address as parameter. Let's update our address variable to hold our account's address, and we will truncate this address so that it will display only its first and last 3 characters. We do that using this truncate string function. Lastly, we save the balance in ethers through this getValueInUnit method available for the ether amount class. passing Ether as the Ether unit. We also convert the result to string to display it on screen. For the balance Solana function, which also receives the RPC and the seed phrase, we obtain the key pair using the from mnemonic method available for the ed255hd key pair class, passing it the seed phrase, and the address will be in this address parameter. Now to construct our Solana client, we first create this WSS URL version of our RPC and construct a Solana client instance with both the original RPC and the WSS version. To get the balance, we access the get balance method available for our Solana client with the address and this parameter commitment confirmed like so. We will parse the balance dividing it by this Lamport's Purcell variable, and we update our variables accordingly in a set state so that they will display on screen. Our UI will consist of a scaffold. With a floating action button to go back to the select chain route, the title of our app bar will be the chain we are connecting to. The body of the scaffold for now will consist of a column. The first element will be the truncated address with an icon button to copy the address to the clipboard. And the second element will be a circle avatar with the connected chain logo and the balance. In our main.dart file, let's delete everything below the main function and make the MyApp class look exactly like this. We need to create a GoRouter class, importing the library like so. And let's create all of the routes we will be using in our app to navigate to the corresponding pages we already created. We can now run our app and it will land in the setup route the first time. We import a seed phrase to recover an account with testnet funds for all 3 blockchains. Set up a password. We can now log in, and we can test all 3 networks and receive the balance in each correctly. I hope this video has been useful. See you next time.